And we have Doug Picha, who will introduce our main speaker, but let me just first say a few words about Doug. So Doug began his career at Children's 38 years ago when it was Children's Orthopedic Hospital. He's right now president of the organization. The year before that, 1979, Doug became a Rotarian, and it was Carl Benke that introduced him. So fun fact about Doug, he was once VP of programs for this institution, and he says he knows a great program when he sees and hears one, and he says today is going to be a tremendous one. So please help me welcome Doug to the stage.
Thank you, Cindy. Good afternoon, everyone, fellow Rotarians, guests. It's really a pleasure to introduce a friend and a colleague, Dr. Mike Jensen, for today's program, and I don't think you're going to be disappointed. Dr. Jensen and his team at Seattle Children's are literally changing the landscape in pediatric cancer by finding a promise for a cure. I'm excited to have him share with you what has transpired in the past 8 years since he became our founding director of the Bentown Center for Childhood Cancer Research at our Seattle Children's Research Institute, which, if all of you don't know, is just down the street on 9th and Stewart. Simply put, his work is testing a cutting-edge treatment that reprograms a child's defense system to attack and kill cancer cells without chemotherapy, radiation, and their debilitating side effects. Pretty incredible. Dr. Jensen is an internationally recognized leader in the field of CAR T-cell immunotherapy with over 20 years experience in research and clinical translation of this therapeutic modality. His entire focus is the application of his work toward childhood cancers. Dr. Jensen graduated from the University of Pennsylvania School of Medicine and then completed training in pediatric hematology and oncology at the University of Washington and the Hutch, with a focus on immunobiology of tumor-specific T cells. After completing his fellowship, he joined the faculty of the City of Hope, where he built the translational research program integrating gene therapy and cellular immunotherapy for cancer. It's here in Southern California where we recruited him to come back home to the Northwest and join the leadership team at Seattle Children's. And the impact he's made since that time has been nothing less than profound. In addition to his duties as director of the Bentown Center for Childhood Cancer Research, he is the founding executive director of CureWorks, which accelerates the progress of immunotherapies for childhood cancers by expanding the access to these therapies for children globally, around the world. All total, to date, 210 patients have been enrolled from all around the world in his clinical trials targeting leukemia, brain, and other solid tumors. And the results have been incredible, which I'm going to let Tim tell you all about. Mike and his wife, Diane, live on Bainbridge Island. They have 3 wonderful children who are now young adults. His newfound avocation is spending time on his boat here in the Puget Sound and up in the San Juans. Please give a Rotary welcome to Dr. Mike Jensen.
Thank you, Doug, for that really kind introduction. It's a real joy and privilege to be here with you this afternoon to share a story that's very much a Seattle story. I've been coached intensively for the last hour by Ken here at the table. I will speak for about 14 minutes and 35 seconds and then have 5 minutes and 25 seconds thereafter for questions. So keep me on task. So I'm going to share with you a story of really deep scientific research into the genetics and the cellular aspects of the immune system when it's confronted with cancer. I think there may be some of you that are going to have an affinity for that part of the story, but I'll also tell you about this really miraculous transformation and translation of work at the bench in the laboratory to the bedside of children at Seattle Children's Hospital. And a fantastic part of this story is that it's taking place just a couple blocks up the street up at Stewart and 9th at the Seattle Children's Research Institute. So this is very much your story as well. So I want to begin by giving you a context for this story. This is the cancer ward at Seattle Children's in 2018. It looks, in terms of how the patients appear to you on this screen, a lot like if you had a camera and you went back in time 25 years, it wouldn't look very different than this. And why is that? It's because children are reliant on old-fashioned therapies to cure their cancer, radiation and chemotherapy and surgery. And if there's any cancer survivors in this room, or if you're a loved one of a cancer survivor or someone that didn't survive, you know that the therapy is almost as fear-rendering as the diagnosis itself. These are crude medicines that go into the body and do tremendous harm. And when they do that to a young child, the harm is potentially lifelong and debilitating. Even with our most intensive therapies, there are many children still in 2018 that come to us that we know we cannot cure, even with the most intensive radiation and chemotherapy and bone marrow transplants. We have a lot of work to do. And that is a affirmation to the whole point of this talk. So what's our mantra at the Bentown Center? We're going to be coming to work. The lights will be on until we create a future for children in which every child that comes with a diagnosis has a cure waiting for them, and the cure is good enough and smart enough that it'll leave their bodies unharmed so they can achieve the goals and dreams that life lays out in front of them. So how might we do this? How might we leave the world of chemotherapy and radiation and enter a new era of cancer therapy where we can harness the power of our own immune systems, this part of our body that protects us from the common cold? Because if we can do that, then cures for cancer could feel no worse than having the flu for a couple days. That is a revolution. So we focus at the Bentown Center on how the immune system works and how the immune system can be brought to bear against cancer cells. And we focus on a white blood cell called a T cell, which is the warrior cell of the immune system. And I want to show you a T cell in action. The T cell will be the small cell, and the large cell has the influenza virus on the inside. And T cells have these receptors that allow that cell to know that there's a danger inside that cell. And what you're seeing is a T cell putting holes in the membrane of that virally infected cell and putting proteins in, and now that virally infected cell is just falling apart and degrading, and we have these wonderful vacuum cleaner cells in the body called macrophages that come by and clean up the mess while T cells go on to find another and another virally infected cell. So this is what our body does naturally so well. How can we turn the tide in cancer therapy by having that happen when the T cell bumps up against a cancer cell? Well, we took an kind of out-of-the-box perspective on this of thinking as the T cell is kind of the hardware, it's the cell phone, if you will, and basically the T cell really needs a new app. And instead of making apps out of computer code, we began making apps for T cells out of recombinant DNA code. And when we down those apps into the T cells in a test tube, now these T cells have something new. They have a new program, and basically they now have a new molecule, a Velcro-like molecule that comes up to the surface of the T cell. So when it bumps up against a cancer cell, instead of ignoring the cancer cell, the Velcro latches on to the surface of the tumor cell, and the alarm system of the T cell says, kill that cell, just like it would be fighting the flu virus. So what do these reprogrammed CAR T cells look like under the microscope? And what I'm going to show you now is how they look under the microscope and how we can now think of a new therapy in which the therapy is basically a tube of blood that comes from the patient, goes into a factory where these CAR T cells are made and comes back to the patient and are infused into the patient without side effects. So here are the CAR T cells in action. The large cells are neuroblastoma cells, a common and deadly form of pediatric cancer, and the little cells running around are the CAR T cells. And I think what you can garner from looking at this screen is that there's very few cancer cells in the test tube already, and there's maybe 1 or 2 left. And so in 45 minutes, these CAR T cells have basically gone through and destroyed all the cancer cells. There's only CAR T cells, and you'll notice that these cells are alive and happy. They can't wait to find more cancer cells. So this is a living therapy that when you put it in the body will become stronger until the threat is gone. It's a very different form of cancer therapy. So with this knowledge and these advances in our laboratories at the Bentown Center, of course, we couldn't just repeat the cycle of make a discovery, write a paper for our peers to read and enjoy, and go get a grant, and go back and cure more mice. We had to cure children, and we had to begin that arduous process, and Seattle Children's Hospital came right alongside us and said, what do you need to start curing children? And that allows me to tell you a wonderful story. This is Greta. Greta, early on, around her first birthday, became sick with fevers and bruises, and her parents were told that she had an aggressive form of pediatric leukemia as a 1-year-old. Greta went through 2 years of chemotherapy, and the leukemia came back. She had a bone marrow transplant, and as you can see, for many of these patients, to keep a patient alive through a transplant, an infant alive through a transplant, takes a heroic team in the intensive care unit, and she survived the transplant only to relapse again several months later. And her parents were going to take her back to Portland, Oregon for hospice care. And it was right at that time that the FDA said to us at Seattle Children's, you can now open your T-cell factory that you've built, and you can make T-cells for Greta and treat her in a clinical trial at Seattle Children's Hospital. So when we enrolled Greta, her bone marrow test, all the red cells are leukemic cells. There should be none of them, and the blue cells are normal cells. So you could see her body was riddled with very advanced aggressive leukemia. So our team got that tube of blood. It went into our T-cell factory at the Bend Town Center, which is on Olive and Bourne. It's that building with the polka dots. So when you see it next, don't say it's just an ugly little building. I think there's miracles happening in that building, because that's where our T-cell factory is, and that's where we made Greta's T-cells. She received her dose. If you see the little test tube in the middle, down at the bottom is a white clump. That's the entire dose of these CAR T-cells that Greta got, about a baby aspirin for about 2 pounds of leukemia in her body. And you could see her getting the dose. It takes about 3 minutes to give this therapy, and it's painless and without side effects. So Greta was one of the very first kids, and we watched her really close. And yes, she had some fever and looked like she had an infection about a week later, and then she got better, and then she started playing again. She got strong enough for her next bone marrow test, and we had no idea. This is kind of like landing the Apollo lander on the moon for the first time. What is going to happen? So she made it through, and we did that test, and we couldn't find a single leukemic cell in her bone marrow. She was in a complete remission. And then with that remission, miracles happen. Miracles like going to kindergarten. There's Greta growing up. We haven't done this just with Greta. We have over 150 children on our leukemia trials, 95% remission rates, and we have children from all over the world that have come to Seattle that have gotten remissions, and most of which have been sustained remissions. So we're on the right track. We have a lot of work to do. So we now have 9 FDA-approved trials, and we have another 3 trials, and we're going after the hardest, most refractory cancers in children. You heard about our leukemia trials. We have a number of trials where we're going to begin to ask the question, can we replace chemotherapy? Can we cure pediatric cancer without 1 drop of chemotherapy going into a child? Have a child diagnosed on a Monday, T-cells made in a week, and that child being back on the soccer field or at her piano recital 2 weeks later. It's an audacious vision, and you have to be brave, and that's just what we do in Seattle. We have trials now for the most refractory types of solid tumors in children, neuroblastoma, Ewing sarcomas, osteogenic sarcoma, and we're taking on the really terrifying cancers in children that are very common, brain tumors, where we've started our first trial where we infuse these cells directly into where the tumor lives in the central nervous system. So we have a lot of work to do. We're just getting started. Of course, what we hope to do is create a future where every child that comes to Seattle Children's has that cure waiting for them, but it would be antithetical to Rotarian values to think that we are just going to keep that here, that it's for our kids and it's not for the rest of the world. So as Doug mentioned, we're creating a global network that we call CureWorks, where we can be a centralized hub for manufacturing products that come via FedEx or maybe Amazon Prime, I don't know. And those products will be made in Seattle, and we'll ship them back so that child can receive this care in their own hospital with the doctors around them, with their family there, and basically globalize our discoveries here in Seattle. That's CureWorks. So what keeps me up at night? It's a struggle. We have a lot of work to do, and we don't give out stocks. We don't have entrepreneurs that are investing in our program. We frequently have to rely on the U.S. government that gives only 3 cents on the dollar to anything that has to do with cancer research. And when you go from curing mice to curing children, it's really expensive. So we have to figure that out. If we only have a limited budget, it means that the timeline to getting to cures for brain tumors and sarcomas is going to take a long time. I don't like that timeline. And what we can do with greater funding and awareness is actually change time, make it happen faster, and make it happen because Seattle Children's is building a new facility called Building Cure on 9th and Terry, where a T-cell factory 10 times the size of what we have in the Bend Town Center is under construction. Why so big? Because we want to make these cures for children all around the country and all around the world. So we're getting help from all corners. We have our Strong Against Cancer campaign with Russell being its champion. We have the word going out in the city and around Seattle, and ideally around the country and around the world. And with that support and a community around us, people like you, I'm assured that we are going to be successful. So thank you so much for your time and attention. Ken, how did I do? I think I might have gone over. Wait a second, I have some more slides, wait. What I'd love to do, and I think is your tradition, is to field questions that you might have about this story and about what we're doing.
We have a question here.
Thank you very much for all that you've had to say. Is the work that you're doing, will it also be applied to adults? Does it work on adults, and will that follow? In terms of
Yes, so actually, we've had a rare occurrence because although we have pioneered this work in academic university settings, this technology is one of the first technologies to make it into an industrial state as a cell therapy. And so we in Seattle know the story of Juno Therapeutics, Novartis and others, and they are really pushing the adult agenda. What we have to do is, because if you create a cure for childhood brain tumors, and that can cure the 9,000 kids a year in the United States that get diagnosed with a brain tumor, that's not enough return on the investment for a company to put into making this cure for children. So the companies are doing the adult trials and getting these cells out for adult indications. If we want kids to benefit from this too, it's a grassroots proposition. It takes communities and I would say venture philanthropy to do it. And I think some of the discoveries that we're going to make in our pediatric world will open doors for therapies for prostate cancer and lung cancer and breast cancer. The first leukemia therapy was pioneered in children and now is the subject of a drug that a doctor can write a prescription for your CAR T cells to be made and come back to you as an adult with non-Hodgkin's lymphoma. It's a really good question.
Hi, the question I have is this similar to the therapy, the autoimmune therapy for adults where they get Pembro, which is the short term for that drug?
Yeah, so it's a really good question. So our body's immune system walks this tightrope walk every day of our lives on planet Earth. It has to be ready to protect us from things that want to come into our body, like a virus or an infection. But it also has to be able to say, oh, you're a normal part of the body, and I can't attack you, otherwise you get autoimmune disease. So Pembro is a recombinant antibody therapy. It's part of cancer immunotherapy. And basically, it's a molecule that you can make in a vial, and it can be given to a patient, and it basically turns off the brakes of the immune system to allow T cells that potentially could attack, that are already in your body, to do that. And it has some significant effects for patients that have melanoma and renal cell cancer and some other cancers, but it doesn't completely cover all cancers. And what it does many times is it causes some autoimmune side effects, mostly in the intestines. So this is part of immuno-oncology, and I think in the future we're going to use drugs like Pembro with CAR T cells in a very sophisticated way to really get the immune system ready to do its thing, especially for these solid tumors that are all throughout the body. Yeah. Any molecular DNA questions? I can't believe. Oh,
I can't go deep on that, but I will talk about relationships, and my family has been close over the years with the Town family, and I know when Jeff and Karen, Ben's parents, joined forces with Children's, they were hoping for no other family to have to endure what they had endured. So what can you tell us about the progress that's been made on that front? I think it was neuroblastoma that Ben had.
Yeah, and the story of how Jeff and Karen came up to the plate for kids, they're the reason that I came back here in 2010. I wouldn't be at this podium telling you this, and this wouldn't have happened without Jeff and Karen being pioneers and being able to have the vision and partner with this guy from Southern California that had this crazy idea about immune system engineering. So neuroblastoma is square in our sights for what we like to accomplish for kids. It's one of the most common aggressive and lethal forms of childhood cancer, and it is one of the most resistant types of tumor to all forms of therapy. So we have one trial that we're probably halfway through, but more importantly, we've learned from that trial, so we have another 3 coming at these solid tumors in kids, with neuroblastoma being a lead. So neuroblastoma has perplexed and vexed scientists and clinical researchers for decades and decades and decades, but I'm hopeful that we're within 5 to 10 years of seeing some really meaningful responses and ideally remissions and then cures.
Thank you for all that you've been doing. A few weeks ago, we had a speaker from Fred Hutch, and I was wondering, to what extent is Seattle Children's working with Fred Hutch, if at all? And in his presentation, he expressed costs of like $500,000 for certain treatments. What are the costs that we're facing in this area?
Yeah. So I think one of the really special attributes of Seattle is the spirit of collaboration in many aspects of our lives here in Seattle, but it's especially true in academics, and it's especially true in our cancer research. So we are fully integrated with our colleagues at the Fred Hutch. We have joint meetings every Thursday. We share our latest data. Some of the apps that we've made at Children's, we've given to our Hutch colleagues to do adult trials and vice versa. It's an incredibly synergistic environment. And our mission at Seattle Children's is to take everything that we can possible and focus it on the needs of the special population of children. Cancer in children isn't the same as cancer in adults. Their body's ability to tolerate the same therapies we use in adults are completely different. So I believe it's appropriate that we have this high intensity focus at Seattle Children's on the cancers that we need to cure. And the Hutch appropriately is doing their important work for adults. And together, if we can do that together and synergize, the world will be a better place. Now, you bring up an important question. So the CAR T cells that have made it through FDA approval are now available for adults with non-Hodgkin's lymphoma. When that prescription's written, the therapy goes off to the company's T cell factory and it comes back, and the insurance carrier gets charged $475,000 for that one vial of T cells. Why is that the case? Well, people in pharma, and if you can raise your hand, it takes about $2.6 billion to get a cancer drug to FDA approval. I don't know if you can add that up for CAR T cells. I would say that academics and the federal government did most of the heavy lifting over the last 20 years to get to where we are today. But it's this issue of return on investment to keep the factories and the stockholders happy with the economics of a company. We're doing this outside of pharma and biotech, our pediatric program, because we know we can never make the case that, well, we can charge $1.2 million to give that cell to a kid, because if they're cured, they'll have hopefully 80 years of productivity. In our world, when we make these cells under the FDA trials, it takes us about $50,000 to make these cells. Technology and Moore's Law is just starting to take effect. We do a lot of things by hand that robots or automation could take care of. I'm cautiously optimistic that in another 10 years, this could cost $5,000. Cancer, the kids that we're treating are terminally ill hospice patients. They've gone through bone marrow transplant and 5 to 7 years of chemotherapy. They've already consumed $2 to $3 million of health care cost to get to the point where they have a tumor we have failed that child by not having a therapy that's ready, and now we're seeing these kids go into remission. So it's going to be a complex discussion, societal one with impact. But again, I'm bullish that if we can keep this in its right frame of mind, we're doing this for kids, it's focused for kids, it's not about the profits that we'll make will be children that are alive and healthy and young adults in the future. If we can keep our compass on that, we'll be successful.
In my previous life, I lived in Russia, and I was involved in projects in the Children's Hospital in the cancer department. And my students were very much involved in children, emotionally helping them to overcome the side effects of chemotherapy. Those were children with leukemia and neuroblastoma and other tumors. And many of them were terminally ill, many of them died. During this process, I learned how important it is to emotionally support children, which was never done back then. So my question is there any research which you did or you saw the effects when you connect what you have been doing with emotional positivity and support coming from music, different types of therapies which are not related to medicine per se, but which help children to heal?
Yeah.
And thank you for your fantastic job you're doing. Thank you.
Thank you. It's a really good point. I think, for any of us in the room who may have been hospitalized with appendicitis or a broken leg, in our childhood, I had that experience. The hospital was a pretty scary place. You had a room and there wasn't anything childish about it. I encourage you, when you can, to come and maybe take a tour of Seattle Children's Hospital. The extent to which they encompass the entire family and create an environment of safety and love and support, even down to having chefs that will make a child a meal from locally sourced organic food any time of the day. When that child's hungry, they get the food that they want. The play therapist, the music therapist. It's a different world. I don't know how to answer your question yet because our therapy is so new, and these children are so sick when we treat them. I don't think it won't be until we can treat kids at the beginning of their therapy with this in a way in which we ask them, we've given you a cure, or do you feel whole and hopeful, and are there emotional scars from that? I'd like to have the ability to ask those questions someday. Yeah.
All right, one last question here.
Thank you. If we were a room full of doctors instead of a room full of Rotarians, would doctors be equally as amazed about your work as we are?
Well, I think so. I think in medicine, the thought that a treatment is something other than a pill or a vial, and it's actually a living therapy that comes from the patient, so personalized and tailored to their cancer that can come back. I know a lot of my colleagues told me that would not be possible. So I went through this. In academia, you write grants to pay your salary and pay the salary of the people that work for you. The first 15 years, I would get back from peer-reviewed scientists, it's too complicated, you can never make it work, the T-cell would never do the right thing, and then we showed that, and then we put our next grant, well, it's too complicated, it can never be done in a clinic, and then we did that, and they said, well, it could never be commercialized and made available to everyone, and now that's possible too. Unfortunately, I had 3 years where the grants were like, I couldn't write them fast enough, And with peer review and your scientific peers reviewing things, my last grant from about 2 months ago said, oh, CAR T cells, it's not very innovative anymore. It's like, oh, 3 years. So, you know, these are amazing times. And I think, you know, for all of us in the room, what I see as a physician scientist in the research, amazing cures are on their way for life-threatening diseases and beyond cancer, autoimmune disease, neurodegenerative diseases. This area of cellular and gene therapy is going to be remarkable. We have to be good custodians of this technology because a lot of people get scared appropriately when they hear we can edit the genes of a human embryo and make a baby, and many of you may have heard the story of what happened in China recently. That takes our breath away because should that be recklessly done, the good that can come from doing this responsibly and carefully will be wiped away. So again, thank you very much for your time. This has been wonderful. Thank you so much.